So up to now, we've covered all the basics that you need to write a Python program. You know how to create variables, how to use built-in data objects such as lists and dictionaries, how to write functions, how to pass data in and out of functions, how to write recursive functions and use regular expressions, and so on and so forth. Granted, we haven't covered every single built-in object, built-in function, and various nuances of Python. That is simply in the interest of saving time. It would take an enormous amount of time, and I am 100% sure I would lose most of you in the process, mostly because it just gets repetitive after a while. Once you know how to use a function, how to use a built-in data object, it's simply a matter of finding the specific syntax or specific attributes that needs to be passed and use that function in your program. So a quick search on Python's online documentation or even a Google search will tell you what you need to know about a function, whether it's a third-party function or a built-in one. And from all the information that we've already know, all the things that we've already learned, it should be simple breeze to implement that particular method, object, or function in your program. So the next couple of weeks, we're gonna look over into refining our programming skills. So far, we've written large codes where you can even write 1,000-line code based on what the project might be. But that may require you to duplicate a block of if statements. For example, when we did our exercise on converting RNA sequences to RNA amino acid sequences, I've seen when you do shift framing, you wrote, some of you wrote the if statements 3 different times, or when we worked on our FASTQ file processing, I've seen same set of lines being copied over from one file over to another. So wouldn't it be nice that if we can abstract such pieces of reusable code into a level above functions, right? We already know that we can write functions that you can recall over and over with different data types and it will process that. But what if we wanted to take that one level further where you can apply that block of logic over different files, different projects, and different programs? So that's where modules, packages, and object-oriented programming comes into play, and that's what we're going to look over for the next couple of weeks. First up is modules, and they are a higher level organization or actually the highest level of organization in Python. By themselves, modules are nothing more than independent Python files. They can actually be ran independently as its own, or they can be ran inside of another program. So, as I said before, given our exercise of FASTQ file processing, the same set of code was written over all 3 different files or all 3 different questions, but you could abstract that using modules or classes one level over, and then you have to reuse that module at different times. So let's take a look at that. And first up, let's take a look at how to use modules before we even go into any further of how to write a module. And for most part, we've actually done this already. When we used regular expressions, we wrote import statements on top of our file, right? We said import RE, which essentially meant we were importing a regular expression module and then using various methods within our regular expression module to work with our regular expression. So such as compile method or the search method or the fetch all method that was part of the regular expressions module, right? Very early on in our course, we used the import from future module to import our division process, right? So it was a true division versus a logical division, right? So that's another way of importing a module. It's either an import statement or you use the from from import statement where you're importing a very specific set of functions from a particular given module. So once we say import a module, whether you use the import statement or you use from statements such as from _ future, three distinct steps are taken by Python. So first step is to find the module, then it's to compile the module, and the compile process is not always necessary, and then finally to run the module. So now let's take a look at each one of these steps in detail. So similar to searching for command, if you type in a command for searching for that particular command in any and all of these directories, and they go one by another. So first searching in this directory, then this one, and so on and so forth. In Python, there are 5 levels of directories that you can search, or 5 places where when you type in an import module, Python will search for that particular module file, right? So what are those? So the first one is the home directory of the program itself. Wherever you're running the program, Python will search for that particular, or wherever you're running the program and where you write the import statement, Python will search for that module within that directory. If it doesn't exist in that directory, then there's a special environment called Python path, and it's all capital cases. If it's not set within your program, it's just essentially means it's default, and depending on which system you're using, whether it's Unix or a Windows or Mac, those default paths are different. Then you can do a quick Google search and find that. But you can set an environment path and set a specific directory or environment path named Python path, and set a specific directory similar to these directories that are local to or are more specific to me. For example, here's one, right, which specifically searches for commands in this particular directory, which is local to my user. You can set up such paths and such paths in your Python environment variable. So when you type in import module, Python will search in that directory space. If it's not found in your environment directory or environment path, or it's not set, then next place Python will look for is in these standard library directories. Now these are usually / user local lib or user lib directories in a Linux system, and they are pretty much standard across all flavors of Unix, whether it's Mac or not. And for Windows, there's I think it's it's in somewhere in your system directory files. I don't recall the exact location, but that's the standard library location where the Python will search for next. Now, if it's not even found in that, then the next path or next location it looks for is this content.p in this .pth file. It's a very specific file, and it's actually a very lesser used way of defining space, your find space or your find directory space for Python. In essence, it's a text file, one path per file, and then you make it available within your Python environment space. So it will search for it in those directories. And finally, if it's not found in that, then Python has something called as site packages, which is where all third-party extensions and modules that you would download using .pip, which is the Python package inspector, or if you just search the Google site and download a particular Python package and install it on your system, usually there's a site package directory that comes along with it. So those are the 5 spaces that Python looks for your module, and they are in order. So your home directory first, then your Python path, then the standard directory or standard lib directories in your entire system, .pth file where you present the directories in order, and then finally the site packages home directory. So once it finds, if the import package, the name that you have passed in, if it's fine in one of those places, the package is imported. The next process is to compile the package, and let's take a look at that step now. Now, when you say import module for the first time, that particular module is actually compiled, and this is where Python actually deviates from Perl or PHP. And if you're familiar with C or Java, Python, well, if you're familiar with, C, Java, or Perl and PHP, you know that PHP and Perl are called interpreters, where they don't actually compile your code, they simply execute the code. When it comes to C or Java, you actually have to compile the code, which means convert your code into bytecode or machine language, where your syntaxes are checked before you actually execute the code, and then when you run the code, well, you are assured that all the syntaxes are correct in some form, at some level. But so that's where Python kind of deviates from Perl, is although Python actually compiles your code at runtime, or converts the code that you've written in plain English into bytecode or machine code before it's actually executed, the top level file, now, the top level file is what you have written so far, where you write the import statements and then write some logic to read in the file, do some calculations, and print out the data. So that's called the top level file, right? When you run the top level file, actually the Python compiles that particular file, but stores that compile or bytecode in memory, so you never see that. However, since modules are meant to be used over time, and it's generally the case that you write what module wants, it does its specific task, and you're not modifying it from one run to another, Python holds on to those bytecodes. It just makes the whole loading process of your Python code and execution process a lot easier and a lot faster. So when you first import a module, if there's no compiled code or bytecode, Python will compile it and then store that or leave that .pyc file behind in one of your paths. So that's where the compile is only if it's needed. So when you first time import it, it compiles. Thereafter, within your search space, which was in the find module that we covered, within your search space, if there is a .pyc file if the file exists, then that particular compiled file is used first. Actually, before it's even used, it's checked to see if so in your search space, you in typical case you will have two files. You'll have let's just, for FASTQ example, you'll have a fastq.py file and a fastq.pyc file. First time you execute, there's just fastq.py file because you wrote that. When you import it, the .pyc file is created. Now, if you made a change to the .py file, there is a timestamp that will differ between the time the pyc file was created and the .py file was .python file was updated. So Python checks for that as well. In that case, a file is compiled again. So if your bytecode is older than your actual source code, then Python will compile it again. If there's no bytecode existing in your search path, then Python will compile your source code and convert it into bytecode. That's why we said it compiles only if it's needed. And thirdly, if your if you don't have the source code file, if you just have the .pyc file, Python will still make use of it because it knows that because your source code has been converted into bytecode and then you can still make use of that. So actually, that in that case, what is used in closed source programs, where you can write your Python file, you can compile it, and just distribute your compiled code in case you didn't want anyone to edit or modify your code, or you don't want anyone to see it in case of proprietary requirements. So you could distribute just your Python compiled file, and your module will still be used the way you intend to use by other parties. So first you find your module, then you compile it, and then finally you execute the module. So those are the 3 steps that are required or that are taken when you import a particular module into your program. All right, so that's how you take a module, or you're going to take a code, you can create an independent module out of it, then that can be reused across projects. And we use the import statement to actually use the file or use the module. And now we know that when we say import a module name, what are the steps that are taken during the import, which is to find the module within your search space, compile the module within the search space, and execute the module within the search space. And now let's move along, and we're going to actually take our case study of FASTQ file, create the module, and see how we can make use of it.